Welcome to my channel. This is Muli. So today's lesson I'll be teaching you how you can go about a lab for stoichiometry or the theory part of stoichiometry, because the same concept is applied. So these are the equipments you should be using when you're carrying out the chemistry experiments. So you need to know how to use these equipments. Then one thing which you need to know also is that this time chemistry will be different. It no longer be like the way it used to be. This time you need to do it on your own. What do I mean? Like in terms of solutions, you need to make your own solutions. For instance, the solution for magnesium and also the solution for hydrochloric acid. Then you start mixing them up. This is how it goes. So what do I mean by this? So for instance, you weigh magnesium of 0.03, then you make a solution. Not so. Then for the acid here, this side, to my right hand side, you know the concentration. Also, you prepare your own solution for hydrochloric acid, whereby even the concentration is known, which you have made. So upon understanding this, you need to remember these formulas. You'll be using them often when it comes to stoichiometry, especially when the concentration is known. Meaning from here, that's where each and everything will come out. So the only thing which you just need to know about your hydrochloric acid is just the volume, because the concentration is known. Once you just know your volume, it will be easy for you to find the number of moles using this equation, which comes from this equation. I've just made the number of moles to be the subject of formula. So the other thing which you need to know your chemical equation. What equation is formed when you mix those two things which you are doing you are mixing. Once you know that, it will be easy for you to do the calculations and also balance up the chemical equation. Like in this case, you balance up. And from there, upon understanding this, you need to know that this mass of magnesium, it's possible that it's not the entire this mass which will be used up in the experiment. No wonder we don't use masses when it comes to more concept. Many people make a mistake by using masses, like they will jump to masses, then here they start calculating. No. Here you need to use concentration. Take note of that, because you'll find that this entire mass won't be used in the experiment. So for you to know how much was used, from the solution for magnesium, you need to go backwards. Using, first of all, you know the number of moles for this known concentration for the acid. Then upon knowing that, also know the number of moles of magnesium. Then from here, after you know the number of moles for magnesium, that's when now you use this formula to find your mass, so that you can be able to know how much mass was able to react with that concentration and that volume. What do I mean? Let us look at this. This is now what is called titration. So for instance, here in this beaker, you put your base here, your base, or in that case, which could be magnesium. Then you put an indicator which will tell us that these two things have done have mixed completely. The experiment is done. It's an indicator which will tell us. So in here in the bullet, there are some changes. That's why we put our acid. So when it comes to the bullet, what I want you to understand is that always know your readings, that they increase as you are going down. So your initial know it, then your final, then you just subtract to find the volume. So for instance, you run this, then you find that the color changes at this volume. So you need to know where it started from there until it ended there. Then you subtract that. That is your volume, which was used for the two magnesium and hydrochloric acid to react completely. So this was an indication. So you do some trials, about 5 of them. So for instance, here the volume you got maybe 21 point something, then the other one you get maybe 23, then the other one 19, but the average, when you add all those 5, then you subtract, maybe it gives you 20. This now will be your volume. Then you use these formulas which I told you, this formula here. So since here you know the concentration here, like for hydrochloric, then the volume, so that you can find the number of moles. Then for you to find the number of moles for magnesium, you need to do more ratio, so that you know your number of moles for this one. Let us look at this question. Like in this case, magnesium, like the same equation which I had shown you, then the volume here, this side, there. Then you asked to find the system mass which was excess in magnesium there. So you use the same formula like I had shown you. Then one thing you need to convert also when it comes to that volume. So just divide with 1000 so that becomes in decimeter cubed. So you find that you have that number of moles for what? Hydrochloric acid. But we're interested in finding what? Magnesium. So now we use the mole ratios. Now here it's telling us it is 1 to what? 1 to 2. So the number of moles for magnesium is 1 to what? To 2. So this is that what you are seeing here. Then I just replace there, then it gave me this. So now for me to find the mass of magnesium, I'll use this formula here, as you can see. Then I just do cross multiplication. Then I replace my number of moles with a molar mass. I'm sure in this case you'll be meeting your what will be in decimal points, so take note of that. So here I'm just showing the basic. So for instance, here have you seen I found the mass to be what? At 0.024 grams, which was what? Used, which is less to what was at the beginning, meaning that it's not the entire mass which was used for what? For magnesium. This is how you go about